Okay, so these are the questions that I want you to do, right? Questions 1, 2, 3, 4, and 5, right? So you've got this sheet, but if not, you can take a screenshot, and these are the questions I want to do. In fact, I'm going to do question 1 for you, right? So show you how it's done. Now, we've got here, it says, determine whether the following pairs of lines intersect or not. If they intersect, write down the position vector of the point of intersection. Okay, so last lesson we looked at vector equation of lines, yeah, and there's an example of one here, okay, with lambda as the constant. But if you've got a second line, okay, if you've got a second line, you can't use lambda as a constant, right? You've got to use a different constant. So we use mu as a different constant. So this represents the second line. And basically, if they are going to intersect, okay, then when they intersect, the I values would be the same, won't they? And the j values would be the same, and the k values would be the same for each particular I, j, and k there, yeah? They've got to be the same because where they intersect, the coordinate is going to be the same. So we can say that this is going to equal this. So 2 minus 2 lambda is equal to 3 mu. Okay, so that's comparing the i's, right? Okay, and then we can say 1 plus 4 lambda equals 4 minus 3 mu. Okay, so that will equal that. And then the k's, 2 plus 2 lambda, or sorry, 3 plus 2 lambda will equal 2 plus 6 mu. Okay, so that's comparing the I, j's and k's. They've got to be equal. So if they are equal, we now work out what lambda and mu is going to be. And the way to do this is I focus on two equations, right? Two equations. So let's focus on the i's and j's, all right? And we'll solve these now like simultaneous equations, all right? Now, in fact, all I need to do here, if I call this equation 1 and equation 2, if I add equation 1 and 2, okay, I'll have 2 plus 1, which is 3, minus 2 lambda plus 4 lambda will give me, so minus 2 plus 4 is going to give me plus 2 lambda, and then 3 mu, add minus 3 mu, they'll disappear, won't they? So I'll get 4. Okay, so that's why I added them. Okay, let's get rid of the mu's. And then I can work out what lambda is. So 2 lambda will equal 4, take away 3. 2 lambda will equal 1, so then lambda will equal 1/2. Right? I got lambda as a half, sub it back into 1 now. And we'll have 2, take away 2 times a half, so I'm putting half in there, equals 3 mu. 2 take away 2 half, well 2 times half is 1, so that'll be 2 take away 1 is 1 equals 3 mu. So that means then 1/3 will equal mu. Okay, that's what 1/3 will equal. That's what mu will equal, 1/3. Now what I've got to make sure is, right, I've got to make sure I check then in the third equation. That's so important. You can't just accept here now that lambda is a half, mu is a third, will mean the lines will intersect. They will intersect for the i's and j's. In other words, the i's and j's will be the same, okay, in this situation, right? The i's and j's will be the same because we found lambda and mu, so that i's and j's are equal. But what about the k's? We've got to be careful to check for the k's, because you can have a situation where it looks as though two lines are crossing, but they actually not. If you look up in the sky and see the two flight paths of planes, the vapor trail behind them, it looks as though they're crossing, but maybe they're not. Maybe in sort of 2 dimensions they are, but in the third they're not. One is a lot higher than the other, of course. One plane could be a lot higher than the other, but when you're looking at it from the ground up, it looks as though they've intersected, but maybe not. Maybe they have for the i's and j's, but maybe not for the k's. So we need to check now with the k's. Okay, so check in 3, and we just literally need to check if it works here. So we look at the left-hand side, 3 plus 2 times a half. So I'm putting lambda in there, and that comes out to be 4. If I check in the right-hand side, 2 plus 6 mu, so 2 plus 6 times mu, which is a third, and that also equals 4. So because they're the same, that means the lines will intersect. Okay? If they weren't the same, if they came out differently, that means then they wouldn't be equal. The k's wouldn't be equal. The i's and j's would be equal, but the k's wouldn't. So it's that situation where one plane maybe is higher than the other, but it looks as though they're crossing. Okay? But they do here. Alright? Now, you need to work out the point of intersection. point of intersection. And to get the point of intersection, then we just sub in our lambda or mu back in here, okay? So maybe it doesn't matter which one you put it in, you can put it in the first one or the second one. So I'm going to put mu into the second one, because it looks slightly easier to work out. So mu is a third, remember? So then I can get r to equal 3 times a third I, put it in there, plus 4 take away 3 times a third j, plus 2 plus 6 times a third k. Okay, so you can work all that out on your calculator and you will get I plus 3j, that's right, plus 3j, plus, I'm doing it without a calculator, you can check with the calculator, plus 4k I believe. Okay, now if you put lambda in here, lambda which is a half in here, you'd come up with the exact same point of intersection. Alright, so that's how you get the point of intersection of two lines. But remember, you compare i's and j's to start with to get lambda and mu, but you need to check in 3. If they're not equal here, that means the k's aren't the same, so the lines won't intersect. If they are the same, lines intersect, you sub in then to work out the position point of intersection.